Imagine you are managing a warehouse full of fruit crates, and each crate contains a specific mix of apples, oranges, and peaches. To keep track of the inventory efficiently, you count them. Let's say one specific crate has exactly 3 apples, 5 oranges, and 2 peaches. Instead of writing those words every single time, you can stack these numbers into an organized vertical list. Congratulations, you just wrote down a fruit vector. In mathematics and physics, a vector is exactly this, an ordered list of numbers that tells you exactly how much of certain base quantities you have. When you bring this into physical space, those numbers act as coordinates. They tell you how far to move along the x, y, and z axis, which means a vector fundamentally possesses both a specific size, its magnitude, and a specific direction. To see why direction matters, think about temperature of a room. It might be 20 degrees Celsius, but it doesn't point anywhere. That is a scalar. But if you are driving a car at 60 miles per hour facing straight north, that is a vector. You need both speed and heading to get the full picture, which we call velocity. The same goes for force. Pushing a block requires a certain amount of effort, and crucially, a specific direction to move it where you want. Now, what happens when you combine vectors? Let's go back to our warehouse. If you add second crate of fruit to your first one, you simply add the corresponding fruits together, apples to apples, oranges to oranges. Visually, if vectors are arrow in space, adding them means taking the tail of the second arrow and placing it on the very tip of the first one. Once you understand how vectors work, you start seeing them everywhere. In computer graphics, your graphics card is constantly calculating millions of vectors to simulate exactly how light rays bounce off 3D objects. In machine learning, a vector exactly works like a fruit crate. But instead of three types of fruit, it might be a list of 10,000 numbers representing a pixel in a photograph or traits of a dataset. And in quantum mechanics, the entire physical state of a system, like an electron spinning, is described mathematically by a single complex vector. So, whether you're organizing a warehouse, programming a physics engine, or trying to understand the fabric of the universe, vectors are ultimate tools for keeping track of reality.